We started working on what became the 800 system in the summer of '77, thinking that this is going to replace Stella in a couple of years. So we did a circa 1977 arcade piece disguised as a personal computer.
Right. But you know what? That really became, that was our second system in a way.
Yes.
And the third system became the Amiga.
Yes.
Was the real genitive.
I wrote an essay about that last night on the airplane because that was one of the questions he posed.
Oh God, I forgot my questions. But
I have them printed out here. Anyway, yeah. Someone asked, what is the conceptual continuity between those three systems? And I have to address that because Jay's only in here now.
Yeah. Well, I remember vividly the day when I had moved to Division Street. Remember? And I
Yeah.
had you guys out because I want to get away from Coin-Op, away from Bristol's
Yeah.
engineering group. And a nice little team over there with you and Larry and Jay. And Jay came over and wanted to understand how video worked. And it took about an afternoon or something
Yeah.
like that to go through and just explain sync and blanking. And he
Yeah.
came back for my cheap video tricks, Alcorn, you know. And,
Yeah.
and that's all it took. And he ran with it. And
Right.
the Amiga was like, wow, what a job. He really got it.
Well,
Blanking was your cheap
I
video
have-
trick to suppress the color burst? To get
Oh,
better
no, no,
colors?
oh, more than that. No, I did all
There was
kinds
so many
of-
cool things done on
I
2600.
did a whole lot of the
Video.
architectural work on the Amiga and the, yeah, I drew schematics.
Did you
that were
work for
easy.
Amiga?
Yes.
Oh, I didn't
I was
know
batch
that.
number
You
3.
worked on the Lorraine?
Okay, and
Lorraine was the
Dave
system.
Morse.
Agnes was.
So I've got
here's the
the
chronology.
Atari documents for the Atari version of the Amiga. I worked on that.
Oh yeah.
We were doing it, it was called Mickey. We just
Yeah.
couldn't put a keyboard on it for the first year, that was the deal.
Yeah, that was a big mess.
I remember you guys
Before
were
I
on,
did all
you guys
the-
were on Scott Boulevard there.
Cinertech also worked out, they had Jay Miner, who was the best guy for doing chips on the planet Earth at that time. And because of our leverage with them buying the other chips, I said, okay, you're going to get the 6502 as a second source, and I'm going to get Jay Miner to work on the part. He says, no, Jay's our guy. So he can still work for you, but he's going to do this thing. And no. And I finally said, look, how many chips do you want to sell us? You got all you want to sell us. You got Jay. So we had Jay came over, and that was the team that came down into Division Street to took this thing and made the next generation.
There's something to be said about the transition too. We hired Joe to come to Grass Valley as both somebody who could program the thing, but as somebody who would just be in Grass Valley temporarily and take the project down and be the
Right.
start of a team down
Right,
there.
All right, evolution from Stella to the Atari 800, which was also called Colleen, and to a certain extent later to the Amiga. A thread that ran, we did the Stella design, we shipped it in the summer of '77. In the spring of '77, Jay and I and Steve and Ron started conversing about what would we do next. By that time we'd heard of the Apple II, and that was about to make it big. And we'd heard of the TRS-80 from Radio Shack, which is about to make it big. So it felt to us like the next logical progression was to build a home computer. But we were a game company, and we were determined to build a terrific game player. Meantime, hardware architecture had been advancing in the coin-op part of the company. The lesson we had already learned at that time from watching the Bob Whiteheads of the world and the Larry Wagners and the Larry Kaplans run away with our hardware was, if you're going to add more hardware support stuff, you should still make it extremely flexible. So instead of jumping directly to a bitmap design alone, what we did is we moved co-processing functions into one of the custom chips, the Antic chip, alphanumeric TV interface adapter, but we also thought it exhibited behavior of its own. It had antics.
Yeah.
And so we did a couple of things. For the playfield generation, instead of just having a bitmap, we had this display list processor which only had 2 or 3 instructions. Basically, it would execute an instruction. It had 16 different or 15 different display instructions and then one other one that I forget. And the display instructions would set for 1 or more lines what mode it was going to execute and where that piece of information was going to come from out of memory. So to implement a bitmap, you would lay out a piece of memory that was the bitmap. You would execute an instruction that said start at this memory location and scan it with this resolution. The lowest resolution was this resolution, 4 color clocks. The highest resolution was half a color clock, 320 pixels across the screen by 1 line. And then a lot of combinations in between. and then some of them were alphanumeric. So we allowed the programmer to set up a display. They could say, make it low resolution characters here for big, scores or whatnot. Then start doing a bitmap. You could change where the bitmap pointed to. You could replicate a display by just changing the pointer in the middle of the screen back to the same place. Lots of tricks you could pull, because the original system design was going to be 4K of RAM, and we wanted to be able to do a lot of things in 4K of RAM. We were still worried about saving money. So we built a flexible system that was easy to do complicated tricks with. The second thing we did is we saw the value of having these sprites and having them be able to move around and reuse them. So the sprite hardware in the 800 was like the Stella hardware, except we put into the Antic chip, it would just read a piece of memory and scan it into this register. So to move this tank around, the software would load a bunch of zeros, the picture of the tank, and a bunch of zeros, which wasted some memory. And then it just had to write a location register to move the tank around. So writing the tank game in the 800 system is trivial. Plus, we had then more color registers. There was a lot of second system effect. But as a game machine, it was real easy to rate pretty good circa 1977, 78 coin-op games.
And that had better color, too.
Oh, yeah. Now, the Amiga was a huge jump, because with the Amiga, of course, semiconductor technology advanced a lot from 1979 when we launched the 800 to 1982 when we started designing the Amiga system, which was at a different company. We got to start with the 68,000, which is a monster.
Right.
There in the Agnes chip, the address generator chip, as it was, had, I think, 32 different address pointers. It had 8 identical sprite engines. The sprite engine could execute an instruction. It would wait for a vertical beam position, move to a horizontal position, start displaying a little piece of memory, and then shut itself off and wait for the next beam position, jump over here and display another object. So putting a lot of doing a football game with the sprite engines in the Amiga would have been really easy. And then it had, a more advanced version of the display list generator that was in the Atari 800. It also had what was called a coprocessor, which was a simple processor that had 3 instructions. The most important which was wait for a beam position, not only horizontal but vertical but horizontal, so it could wait for like that spot, and then start copying a bunch of data into some registers, and then do a conditional branch. And this is running in parallel with the 68,000, which is busy figuring out what to display next. So you could do very elaborate low memory displays with the Amiga. The third thing that the Amiga did is we had some people on the design team from Apple, as well as from Atari sprite game-driven places. And so they talked to us about how to hardware accelerate bit blitting, as it's called, of cutting and pasting things into displays. And so we built a bit blitter engine that could take 3 different chunks of memory, shaped and oriented anywhere in memory, pull them up, bit align them to a resolution of 1 part in 640, take these 3 bit streams at once, and do any of 8, what is it? We had an 8-bit register that would pick any of the decoded 8 possibilities of these 3 bits, so we could do any logical function on these 3 bits, recombine them in any way we want, and write that back into memory as the 4th operation. So you could have the outline of, let's say, a Smurf, and its bitmap, and a background, and the bit blitter could, in hardware, pull them together, do a cut and splice, and paste back into memory in the time it took to read and write the memory locations.
Wow.
It was an animation machine. It was designed to do cartoons at a time when VCRs cost $1,000 instead of $200.
Right.